Okay, so on to number 11. So 11 is part of our new section that we learned after the quiz. So this wasn't on the quiz review, so this is like the new fresh stuff for us. So give the maximum number of zeros the polynomial may have, then use Descartes' rule of signs to determine how many positive and negative zeros the polynomial will have. Okay, so the maximum number of zeros, that's the easy one. So the maximum number of zeros is just looking at the degree. So now, like I said in 10, when it's multiplied out, like this one is, there's no parentheses, nothing that we have to multiply together. We just look at the highest exponent, which is 8. So the degree is 8, so the maximum number of zeros I can have is 8 also. So the degree matches with the number of zeros. Okay, so now I'm going to use Descartes' rule of sign. So remember, positive and negative, we are looking at the same, we're looking for the same thing. The only thing that's different is for the positive, we're looking at f of x, and then for the negative, which I will do up here, we're looking at f of negative x. Okay, so let's start with the positive, just looking at f of x, which is my original function, so we don't have to do anything. So 12x to the 8th minus x to the 7th plus 8x to the 4th minus 2x cubed plus x plus 3. Okay, so what we're doing is we are looking at our signs. So what I usually just do is I write my signs of my coefficients in front. So 12 is positive. Negative x to the 7th, that's negative. We have a positive, a negative, a positive, and another positive. So then we're looking at the number of variations that we have in our signs. So that means from a positive to a negative, that's a variation. That's a change in a sign. So that's 1. And then we go from a negative to a positive. Well, that's another change. So that's my second. And then a positive to a negative, that's my third. Negative to a positive, that's my fourth. And then positive to a positive, there's no change. So we have 4 positive zeros. Now remember that other part of our rule. So we're going to take our 4 and we're going to subtract 2 to get 2. So it could be 4 or 2. So then I'm also going to take my 2 and subtract 2 and I get 0. So 4 or 2 or 0. Now, if you were like, let's just keep going, well, 0 minus 2 is negative 2, which doesn't make sense, so that's where we stop. We stop at 0. Okay, so now let's look at our negative. So our negative, the only thing that's different is now wherever there's an x, we plug in negative x. So negative x to the 8th minus negative x to the 7th plus 8 negative x to the 4th, I might run out of room here, minus 2 negative x cubed plus negative x plus 3. Now, remember with these, whenever it's an even exponent, the negative goes away because a negative times a negative makes a positive. So with this, the negative goes away and it stays that 12x to the 8th. But when you have an odd exponent, the negative stays there. And so a negative and a negative here, that means we're going to add x to the 7th. The negative x to the 4th, it's an even exponent, so the negative goes away, plus 8x to the 4th, and then minus 2 times negative x to the 3rd. The negative is going to stay there. It will multiply with the negative 2 to make it positive 2x cubed minus x plus 3. And so now, once I've simplified all of the negative x's out, now I do the same thing. I look at my signs of my coefficients. So I have a positive 12, positive 1, positive 8, positive 2, negative, and a positive. So I do the same thing. I'm looking at where my variations are. Positive to a positive, no change. Positive to positive, no change. Positive to positive, no change. But now we go from a positive to a negative. That's 1. And then we have another negative to a positive, that's 2. So we have 2 negative zeros. Now just like we did with the positive, we subtract 2 and we get 0. So it's 2 or 0. So remember, the only time you stop subtracting 2 is when you get to a negative number. So if we subtracted 2 again, just like we did over here, we'd get negative, which doesn't make sense. Okay, so that just sums it up for number 11. So, it's just basically, you just have to know all of the rules to get us kind of to where we're going for number 12. So number 12 is asking you to list all the potential zeros, then find all the real zeros, and write your answer in factored form. So just start us off, we're going to list all of our potential zeros. So our potential zeros, remember, we are looking at all of my factors of the constant, which my constant is 8. So it's whatever number doesn't have a variable attached to it. So my factors of 8, well, 1 goes evenly into 8, 2 goes evenly into 8, 4 goes evenly, and 8 goes in evenly. And so then it's divided by all of my factors of my leading coefficient. Well, my leading coefficient here, there is no leading coefficient. When there is no number, we assume it's 1, and so it's just plus or minus 1, which we really don't need because 1 over 1 is 1, 2 over 1 is 2, 4. So my potential zeros are just plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So now that we found all of our potential zeros, we're going to start looking for all of our zeros. So that's when you need to get your calculator out. And so once you get your calculator out, we are going to graph our function. So into our function, into our calculator, we are going to plug in our original function. So x to the third plus 7x squared plus 14x plus 8. And then we are just going to graph that. So remember, we're looking for a 0, and we're looking for where it crosses the x-axis. That's what a 0 is. So if we look at our graph here, it crosses at a bunch of different ones. It looks like it crosses at -1, it crosses at -2, and it looks like it crosses at -4 also. It does not matter which one you pick. You can pick any of the 3. It's your own choice. Not one answer is going to get you a more right answer. So I'm just going to go with -1 just because it's easier to multiply by. Okay, so -1, that's my 0. So remember, we keep the 0 outside. And then inside the house goes 1, 7, 14, and 8. Now, I didn't need any placeholders because my exponents go down sequentially, 3, 2, 1, 0. Okay, so the 1 comes down, and then 1 times -1, -1. 7 plus -1 is 6. 6 times -1 is -6. 14 plus -6 is 8. 8 times -1 is -8. And 8 plus -8 is 0. So now that I've done that, now remember, if you don't get a 0 here, what that's telling you is you either graphed wrong or you did something wrong in your synthetic. The whole point of looking at our graph is so we don't have to do trial and error until we get one that has 0. So we should have 0. Okay, so we bring down my factor. So remember, my 0 is at -1. So my factor is at x plus 1. And then we use this. So what's left? So what's left is x squared plus 6x plus 8. So now that I have a quadratic, so I started off with a third degree polynomial, and so you have to start with synthetic. And so I started with synthetic, and now I have a quadratic. So I have 2 options. I can either solve by factoring or solve by the quadratic formula. Now I'm going to solve by factoring because I can factor this one. And so I know that x squared plus 6x plus 8 factors to be x plus 4 and x plus 2. And then I'm going to bring down that x plus 1. So at this point, it's fully factored. And so now, when it says write your answer in factored form, I already have that done for me. So my factors are x plus 1, x plus 4, and x plus 2. So that part's totally done. We just have to write f of x equals all of that. So now to find our real zeros, all we have to do is, that just means we're setting our whole function equal to 0. When our function's equal to 0 and we have all of our factors, we can just set all of our factors equal to 0. So x plus 1 equals 0. I subtract 1 to get negative 1, which is what I had already over here. And then subtract 4 to get negative 4. Subtract 2 to get negative 2. So my real zeros are negative 1, negative 4, and negative 2. And that is all you have to do for number 12. So the last one, we're going to finish off with number 13. So number 13, we're solving in the complex number system. That should be a hint. When it says solve in the complex number system, it should be a hint to you that you are going to get imaginary answers. And then it says then write the function fully factored. So we notice that, or you should notice, it's to a 4th degree. So remember what we talked about. When it's to a 4th degree, you definitely are going to start off by using synthetic. So I am just going to go into my calculator again, and into my calculator. So again, if you don't know how to get there, we just press y equals. I am going to plug in my original function. So x to the 4th minus 4x cubed minus 44x squared plus 196x minus 245. So I am going to graph that. And you should see that it hits it at 2 spots. Again, just like before, it doesn't matter which one you pick. So it looks like it hits it at -7 and +7. So I am just going to pick -7, I think. Let's see what I did already. Yep, I'm going to go with -7. And so that goes on the outside of the house. And on the inside, we're going to put our coefficients. So these, again, they go down sequentially, 4, 3, 2, 1, 0. So you don't have to worry about any placeholders. So 1, -4, -44, 196, and -245. So remember, those are just our coefficients in front of the x values. So the 1 comes down, and then 1 times -7 is -7. -4 plus -7 is -11. -11 plus -7, sounds like I'm rhyming here, is 77. -44 plus 77 is 33. 33 times -7 is -231. When I add those, I get -35. -35 times -7, oh my goodness, is 245, which add those together, we get 0. Okay, so now that I have that, I got 0 as my remainder, which is what we want, what you should be getting. And so that means I'm going to bring my factor down. Now remember, if my 0 is at -7, my factor is x plus 7. And then I have what's left. So I have x cubed minus 11x squared plus 33x minus 35. Now at this point, what I would do is I would look at this and I would think, okay, can I factor this by grouping? And I can't, because if I were to factor this out, I would not get the same thing in each parenthesis, so I can't factor by grouping. So what that means is we have to do synthetic again for this one. So into our calculators, we are now going to plug in our new polynomial, what's left. And so x cubed minus 11x squared plus 33x minus 35, and we're going to graph that now. Okay, so when we graph it, what you should notice is it hits it at 7. So it crosses the x-axis at 7. So that's what's going to go on the outside. And we're going to do synthetic one more time with my new function. So my coefficients are going to be 1, negative 11, 33, and negative 35. So I'm using this new one to do synthetic on. So the 1 comes down. 1 times 7 is 7. Negative 11 plus 7 is negative 4. Negative 4 times 7 is negative 28. 33 plus negative 28 is 5. 5 times 7 is 35. And they add up to get 0, which is what we want, which is what we need. And then now we can start bringing everything down. So I'm going to bring my x plus 7 because I don't want to forget that one. I'm going to bring that down. I'm going to bring down my factor from 7, so x minus 7. And then I'm going to write what's left. So what's left is that x squared minus 4x plus 5. So now that I'm left with a quadratic, I'm left at the step where I think, okay, I can either factor or I can solve using the quadratic formula. And so, of course, I always try and factor. I think what two numbers multiply together to get me 5 and add up to get negative 4. Unfortunately, there is nothing. So we have to use the quadratic formula, and because we're now at a point where we can start solving for our zeros. So x plus 7 equals 0, x minus 7 equals 0, and x squared minus 4x plus 5 equals 0. So now I can start doing the quadratic formula over here. So remember, quadratic formula, opposite of b. So opposite of negative 4 is positive 4. Plus or minus the square root of b, negative 4 squared, which is not 64, it's 16, minus 4a, which is 1, times c, which is 5, all over 2 times 1. And so 4 times 5 is 20. 16 minus 20 is negative 4, which we expected because the problem said solve in the complex number system. So we get the square root of negative 4 all over 2. Now remember, when we're simplifying this, do not, and I repeat, do not start to simplify your 4 and your 2 yet. You have an addition sign. You can't simplify those yet. You have to be able to simplify both. So the square root, let's first just think about what's the square root of 4. Square root of 4 is 2. Well, with that negative, the square root of negative 1, we know is I. So the square root of negative 4 simplifies to be 2i. Now is when I can simplify, because I know 2 goes evenly into 4 and 2 goes evenly into 2. So I can simplify to be 2 plus or minus I. I can solve for these guys up here too. So x is equal to 7 and x is equal to negative 7. So now I have my 4 zeros. My zeros are at negative 7, 7, and 2 plus or minus I. Okay, so now that I have my zeros, I can write it in its fully factored form. So what I usually do, just to like help myself out, is I usually write out the zeros. So I know one of my zeros is at negative 7. One of my zeros is at 7. Another one is at 2 plus I. And I'm going to squeeze it in. Another one is at 2 minus I. So remember, your zeros is what x is equal to. Your factors is when everything equals 0. So what we're going to do to have this equal 0, we need to move the 7 over. So we add 7 to get my factor of x plus 7. Here, we would subtract 7 to get my factor of x minus 7. Here, I would first subtract 2 and then subtract I to get x minus 2 minus I. And then with this one, I would subtract 2 and then add I to get x minus 2 plus I. So now it's fully factored, and I can write that as my f of x. And so that does it for number 13. You can celebrate. and enjoy. There's your last words of wisdom for all of my 4 lovely kids that have been here for all of these videos. Okay, see you guys tomorrow. Get a good night's sleep.